Start. So hello and welcome to today's event titled Discover Our Nanotechnology, Rehabilitation Technologies and Musculoskeletal Science MSc programs. Thanks very much for joining us. My name is Kate Thomas. I'm the Events Officer for the Faculty of Medical Sciences here at UCL and your chair this afternoon. We're hoping this session will address those course-specific questions you may have and will help you to gain an insight into what it is really like to study on one of our exciting MSc programs. I'm delighted to welcome today's speakers, Gavin, Anne and Chaozheng, who will provide us with a summary of our nanotechnology and regenerative medicine, rehabilitation, engineering and assistive technologies and musculoskeletal science MSc programs. There will be a Q&A session and plenty of interactive opportunities for you all to join in throughout today's session. This session is being recorded and will be made available on our website following today's event. We're here to respond to your questions, so please share those throughout using the Q&A function on Zoom. Now to introduce our speakers, we have Gavin Gell. Dr. Gell is the program lead for the MSc in Nanotechnology and Regenerative Medicine. He leads a research group who are developing our understanding on how materials interact within biological environments to create better biomaterials that have reduced failure rates and have increased functionality. This includes materials that induce regeneration, tissue engineering, and improving nanoparticle targeting. And Anne van Hoostenberg. Dr. Anne van Hoostenberg is the Rehabilitation, Engineering and Assistive Technologies MSc Course Director. She has over 20 years experience in university education. She trained as a microelectronics engineer before specialising in medical engineering during her PhD. Anne's presentation will provide you with an overview of the course content, our pedagogical approach and clinical collaborations. She will also address what the course looks for in prospective students and your career prospects after a degree with us. And Chaozheng Liu. Chaozheng is Professor of Orthopedic Bioengineering and Program Tutor for the UCL MSc in Musculoskeletal Science. His current research is directed towards the biomaterials processing and development of enhanced medical devices for treating musculoskeletal disorders, tissue repair and regeneration. So before I hand over to Gavin, I'm just going to pop a Mentimeter link into the chat ahead of Anne's presentation, which will be following Gavin's. So if you could just take a moment or two just to answer that ahead of the session, that would be fantastic. Perfect. Great, now over to you, Gavin.
Hello everyone, thank you for coming along. So as Kate said in her nice introduction, I'm the lead for the MSc in Nanotechnology and Regenerative Medicine, and I do research in that area. So I'm going to share some slides with you. I've got way too many slides for you. Oop, too many things open. Oops, let's just get the right slides up. There we are. Can you see that? Am I doing the wrong thing?
Yep.
Yeah, we can see.
You can see, great. Nanotechnology and regenerative medicine covers kind of a few different areas, including tissue engineering, regenerative medicine, creation of new, better biomaterials, and understanding how materials as a whole interact within the biological environment. I'm going to quickly give you kind of like a tour of the different modules that we are hosting. Let's just, I suppose, the overview of the course is, yes, we engage you with kind of real research in the areas. You'll join real research groups, do your projects in these areas. Lots of exciting kind of different tissue engineering kind of topics. We have some excellent stem cell researchers, and also we're heavily involved in nanomedicine research. We have lots of different module leads, some new module leads, some like me who've been here a bit longer, who are kind of experts in their field and will deliver specific modules in their area of research. So there's two core structures. We have a 90 credit research project, which is 50% of the course. And we also have an alternative one, which is where you do a 60 credit research project and you'll do 2 more additional optional modules. So the year kind of looks like this, where you'd have a lot of your talk components in the first term. And then if you're doing the 90 credits, there'll be some in the second term where you're kind of doing a mixture of the research project and the talk components. And then the third term will be entirely on your research project. And then if you do the 60 credit project, we still try and start you to be engaged in your research project around the first term where we have our project days. But because you've got lots more modules to do in your second term, you'll be focusing on your research project in the third term. So just go through some of the core modules that you'll be teaching on. The Nanotechnology Medicine is a module which is led by Kate Ricketts, and this focuses on different applications of nanoparticles and nanotechnologies in medicine, including for the diagnostics purposes, for targeted drug delivery, but also in terms of understanding how we characterize these interactions with biological fluids and cells on the nanoscale, which isn't trivial. So I don't want to go into too much about this. We do spend a lot of time talking about nanoparticle targeting, which obviously means that we can get more of the drug where it's needed at higher concentrations without systemic effects. And we talk about how this hasn't been so successful so far in terms of translational efficacy of the reasons for that. We talk about why size matters, which we talk about the different definitions of nanoparticles and nanomedicine in the field as well. And we also talk a little bit about COVID-19, which is one of the success stories in nanomedicine. There's a really cool poster event that we have for this module where we engage the students with a particular researcher who's doing nanomedicine at UCL, and they'll present that work, which you have some cheese and wine or some drinks with it. I lead a module on tissue engineering, and this is kind of like a background topic in terms of how we can create materials that can direct regeneration of tissues. And we talk a lot about different types of tissue engineering in terms of making tissues inside the body, where we put materials inside the body to release factors or be designed to re-engineer tissues inside the body. Or I think what most people think about tissue engineering is making these tissues outside of the body. We discuss about decellularized scaffolds and the potential of making whole organs. This is me speaking on a BBC podcast a little while ago, where I kind of highlight some of the hurdles that we have to overcome to be able to make these whole organ tissues. The assessment for this is quite interesting, where we have to do an open examination, where I'll just give you a tissue engineering paper and then you'll give me a critical analysis on it. Another module, another core module we have is biomaterials and regenerative medicine. And this module, which is led by Professor Wenwei Song, gives you an overview of materials in medicine and how we can change material properties to direct cell behavior. There's a basic research methodologies, which is common for all our courses within the Division of Surgery, and where we have basic statistics and try to teach you in terms of some basic research methodology approaches. There's also a practical module. Most of our projects are lab-based projects. There are some, if people want to do more data analysis projects or clinical projects, but the core projects, or most of them, are lab-based projects, and for that you need to be familiar with cell culture. So this module provides you with basic cell culture techniques and also how to characterize cell behavior. One of the optional modules is looking at how we can translate these innovative technologies into patients. And we will take you, or Amy, who's the project, the module lead, will talk about how we can translate ideas from having the new technology to having a real commercial product that can benefit patients. I know everyone's really excited about the research projects, which is obviously a key component of the course, and I think of what attracts people to UCL as a whole. We have a whole list of different projects that are available for you. We'll have a little project booklet and then a project day where students will talk about the projects. Is that right? PIs will talk about their projects, supervisors will talk about their projects, and then students can ask questions, and then they'll select the project they want. We want them to be engaged in their projects before we break up for Christmas, so then they can do some background and start working on their projects. Lots of cool projects in lots of different areas in terms of both biomaterial research, 3D printing, nanocomposite vascular grafts is an area of research in our division. Lots of nanoparticle research projects, different types of nanoparticles, gold and lipids, mRNA targeting nanoparticles, like the COVID ones. Tissue engineering, lots of different types of tissue engineering products from different tissue engineering projects, looking at directing stem cell differentiation or making new tissues for different types of tissues. We have quite a strong D-cell component. You may not be familiar with this, but decellularized scaffolds is an area of research that is interested tissue engineers, and we always have some research projects in this area. Just wanted to mention some of the other activities we have, which are co-curricular. So in addition to like the core or the optional modules, we have research seminars that occur every other week, which we invite the students to. And these are both about researchers within the division and outside the division or elsewhere. A few years ago, we had Mark Post, who did the synthetic lab burger. So we have those, which we want the students to engage them in the research. We have personal tutor meetings. I'm sure you know what personal tutors are, but this is an idea that you have somebody who's going to be able to be contact for pastoral care, but also to help you with your studies and your career. We also have workshops. So we have an interdisciplinary cohort of students from more physical sciences or more biological sciences. And we realized that we need to help them by having some workshops, which are on basic biology. And these are additional for those people who are certainly from the more medical or physical sciences who maybe don't know so much about the cell biology. And then the other thing we do, especially in the autumn term, is a journal club for the students. So we think that the critical engagement in research is really a key learning outcome for the master's course. And some of the assessments are aligned with critical analysis of research. So we have this MSc Journal Club where all our students have to present and be critical of research papers. Good. So like I said, we have a very disciplinary cohort of students and international. Some are full-time. We do have some part-time. As you can see here, it was 60% male. I think that's changed hugely over the last few years. We now have more females than males on the course. And we encourage like people from different backgrounds to come on the course because we are aware that this is an interdisciplinary field. And we need to have people from different backgrounds. So the spring term, we have more talk components and also the research projects. I'm not going to talk much about that. I just want to say a bit about in terms of the learning environment. We have face-to-face lectures and practical sessions, but we also have online interactive learning as well. We try and one of the advantages of being in a hospital is that we in contact with clinicians. Some of these clinicians will teach you. and they give us real world challenges that we can help address. And that's both in terms of the projects, but also in terms of the assessments that we're doing. We also want to connect our students to the wider regenerative medicine and biomaterial community, which is strong in London, and also within the academics that are in our environment who teach in the course. And I think this is an important component where we encourage students to become members of societies and attend conferences. Good, you can ask me about careers afterwards. I realise that I'm already out of time. So I'm going to stop there. So thank you for listening to me. Please ask me questions. I'm going to be hanging around.
Thanks very much, Gavin. Now over to you, Anne.
Thank you. Hi, everyone. I hope you can all see me. I'm going to share my screen in a moment. Thank you already for the student who answered the Mentimeter questions. I know there's only 2 of you on the call at the moment, so it's going to be pretty casual chat. I'm going to introduce first a few notions about UCL, because to us it's really important. You're not joining just an MSc, you're joining a university, and there is really a lot to benefit from joining a university like UCL. So I'll just whiz through a few slides about the university, and then we'll take it from there and discuss the program in particular. I hope you can all now see these slides about UCL. So just very basic, but UCL is a historic environment, and this has a lot of implications in terms of what we represent. Our reputation precedes us. So obviously students join us for the courses, but also for the reputation of having done a degree at UCL. The network you will create by being a student at UCL, the other people you will meet, this is the sort of benefit that you get from a degree within such a worldwide university. The network will follow you through your career. You'll have contact with people that you will be able to use and touch base with over the whole of your professional career. We have LinkedIn groups with our alumni, so alumni stay in touch, and every now and again you'll have a question, something that somebody else has much more expertise than you in. Being part of a university and a cohort of students within UCL gives you great access to a wide range of expertise. We're one of the best universities in the world, regularly ranked in the top 10 or top 5 class. So we're really proud of that. This is something we work really hard to maintain, both in terms of our research, but also in the quality of our education. We have a huge number of academic and research staff, which means that when you do projects with us, you get very one-to-one or one-to-few interactions. We have a mix of students as well, and again that contributes to the diversity of our cohorts. We welcome the sharing of ideas, the discussions of different points of view in degrees that are, as those that we're presenting to you today, peripheral to healthcare. It is also hugely beneficial because you get to learn about health systems across the world, and for students who are considering international careers, this benefit just from having been in a classroom discussing different points of view, different perspectives, different practices in different countries is hugely beneficial in terms of knowing where to go for the next step in your career. We have over 200,000 alumni that are contactable. Because you were at UCL, you'll contact somebody else that was at UCL, and that gives you a direct entry into a huge network. So we are very proud of our history, but we're also very much forward-looking and looking towards the future. And we know that all students are going to be the future of our university. So we really work hard to inspire you, to educate you, to train you, to form you, and to prepare you to deliver the future that we want to see in the 21st century. So we're today opening up. Several of us are on the call. I'll tell you a little bit more about myself and Hu Bintao, my colleague, who are on the call to answer your questions. And I'm already thanking you for joining this. So I'm going to move away from this set of slides and talk now about the Rehabilitation Engineering and Assistive Technologies MSc. So our MSc is driven by the Center for Rehabilitation Engineering and Assistive Technology, which in short is CREATE. CREATE is a really important innovation from the university. It's a mix between a university research centre and a very close collaboration with the Royal National Orthopaedic Hospital, which is a specialist orthopaedic hospital in London, one of 13 in the UK. And because of their specialism in orthopaedic and rehabilitation, we have very close contacts with our colleagues for research as well as for our education initiative. We also are cited, together with the hospital on site, is the Aspire charity that have specialized in supporting reintegration of people after spinal cord injury. And working with them enables us to really cover the breadth of knowledge from not only just rehabilitation engineering, but also all of the assistive technology that help the reintegration of people after injury into an active life in the community. We also have close links with industry, which enables us to work on product development. I'm aware of the fact that I haven't introduced myself yet. I will in a moment. The reason why my name isn't presented on this image of the teaching team, I'm sorry, this bar is a little bit in the way. Let's just see if I can remove it. There we are. I hope you can still see the screen. So the reason why my name isn't there is because I will not be part of the teaching team next year. I'm presenting the program this year. I created the program. I have led it for several years, and I'm now handing over to Dr. Hubin Zhao, who is on the call. So if you have any questions, and I've seen some on the Mentimeter already, we'll be addressing them together. Other than Hubin, we have a core team of 3 other senior lecturers and professors who will be delivering the content, as well as a huge number of guest lecturers. I wasn't able to collect pictures of everyone in terms of the guest lecturers, so I haven't put any. But generally speaking, we have expertise in instrumentation, both implantable and surface instrumentation. We have telemetry. We have expertise in rehabilitation robotics, in haptic systems, in interactive assistive technology, smart wheelchair, electronic devices. So you'll have access to a breadth of expertise, and all of us have expertise in working with people, and this is crucial in our field. We cannot develop new technologies in abstraction of the needs of the people we try to help. So we work with patients, we work with people living with chronic conditions, and we work with clinical teams. In terms of whom we work with as well, we work with all students. And I put here a few pictures, again, because I do all of my slides really rather late. I haven't got pictures of our students like Gavin did. This is a picture that represents anybody who could be our students and what they do. So we have worked with students from, as I said, different backgrounds. Some of our students have different degrees of disabilities or abilities. Some of our students have different degrees of awareness and knowledge of technology. So we always, every year, have a mix of backgrounds. Some students will have a straight engineering background, others come to us from neuroscience, from biology, from different degrees of physics degree maybe. And this mix gave us a great team to work together on solving real problems as part of the group projects by bringing together the range of expertise that you have when you do not have students, everyone from the same background. This is extremely important for us. We also have, as I said earlier, diversity of origin. Therefore, diversity of experiences and diversity of expectations of what a rehabilitation engineering degree will provide you. And this, again, contributes to creating a really dynamic environment. I just wanted to have a quick slide before I carry on about the content, about the impact of COVID throughout the year. COVID is still with us, will still be with us when you start with us next October. We have managed this year to deliver all of our courses face-to-face, where we had one set of courses that were designed to be delivered online because they were a course that was mixed with a wide range of different classes, different students. Otherwise, we were able to have labs. Our students are currently working in the lab. They're delivering their group projects. They're delivering their coursework. They're doing face-to-face presentations. They're learning presentation skills. They're learning how to present and express themselves clearly. They've had labs in the anatomy lab. So they've had a range of hands-on experiences. They're still doing it. They're doing, some of them will be doing electrical simulation next week, which is really exciting. They'll be testing it on themselves, experiencing it firsthand. So we've been able to deliver all of this whilst following UCL guidelines and generally being safe. We've had very little impact of COVID this year. The situation could change and will change. It could change for the better or the worse. So we're very aware of that. But we also know that the year before this year, we were able to deliver a very high quality program moving almost entirely online. So we know we have demonstrated our ability to sustain high quality education, whether we're doing it in person or online. But we're really hoping that we'll be working online. This is a really loaded slide, and to some extent, let's just ignore the detail of the text and just look at a few of the pictures and the keywords that I've highlighted it here. What we want to teach you in our program, and this is across modules, I haven't presented the individual modules here. The program was conceived as a whole, as a combination of modules that together build the knowledge necessary for you to understand the needs of patients, end users and clinicians, for you to understand the appropriate statistical methods and research methods, for you to understand biomechanics and key concepts of assistive technologies and robotic rehabilitation. You'll also understand the effect of different pathologies and injuries have on the function of the body, which is essential to understand how you can help people who live with these chronic conditions. You'll understand also the importance of the social and environmental context. And this is where having a mixed class with students from different countries is fantastic. It gives us such exciting discussions. We realize that we are so used to our own expectations of our own countries, and it really matters when we get together and realizing what everybody expects is different based on the culture we come from. And all together, these will give you the knowledge to design, build and improve assistive and rehabilitative technologies. We also want to develop other skills that are more transferable and often less thought about, and yet they are the most important for your career. Because by focusing our program when you conceived it in making sure you acquire these skills, we know that you can take a range of jobs after the master's in a range of countries with a range of different outlook. You may go in research, you may go into a sales role in a large company, or you may go into a design role in a very small company. Maybe this is a startup, maybe this is a company that's got a key product already. And by making sure that you learn to think analytically and critically, by making sure that we teach you problem solving, both engineering, scientific and reflective skills. We teach you how to read scientific articles. As Gavin said in one of their modules, we also do critical analysis of papers. We teach you to write scientifically, but also to summarize effectively your thoughts and ideas. Extremely important. If you have 2 minutes to convince somebody to give you 10 minutes of their time to listen to you more, you need these first 2 minutes to really be the hook that attracts the attention of the person you're talking to. Finally, we also teach you to critically appraise research data. This has never been so important as in the years of COVID. You need to know what your data is telling you, you need to know what you can trust, and we really focus on critical appraisal of research data. Not everything that's out there has the same value. We try to teach you about efficient and effective interactions with other people. Interdisciplinary research is really important, but also interdisciplinary development, interdisciplinary communication. So we really focus on that. We focus on communication, both in terms of, as I said, speaking and writing effectively, but also being able to listen, to reflect and understand, to negotiate, to compromise, which is a real focus on our work. We make a lot of our work being group work, so that you learn to work in multidisciplinary team. You also learn project and time management for yourself as well as within a group. You learn to delegate. You learn how to work with people with different skills. We take an inclusive systems approach, and we apply engineering and program skills to the whole of the rehabilitation domain. We train you to become engineers. And an engineer is a person that can see any situation in life and take an approach which is a problem-solving approach, which can really holistically appraise the situation. We also teach you to express yourself for different audiences, so that you may one day be speaking to a TV or radio host, another day you may be speaking to children. I do a lot of work with schools, primary and secondary schools. We do work with different audiences in terms of the patients as well and the clinicians. So you're going to learn all of that through a series of presentations and workshops based on communication. And finally, we teach you to learn and manage your own learning experience, not just for the time you spend with us, but also because we know that as engineers, you will continually learn throughout your career. No 2 years will be the same, and every year you'll tackle a new challenge. Every new challenge you'll tackle, you'll have to learn on the job, appraise the situation holistically, as I said earlier, and continuously develop your professional knowledge. Finally, We really focus a lot of attention on understanding the notions of ethics and good practice, which are extremely important. Again, this has been brought to the fore with the COVID situation, as well as talking about entrepreneurship and intellectual property. I'm aware of the time, so I'm going to skip quickly through the modules and not give you too much detail. We have a range of modules that together give you a very sound grounding, a theoretical and practical grounding in the basics necessary for developing new technologies. So whether that be anatomy and physiology, whether that be concepts of assistive technology and rehabilitation, core biomechanics are essential if you're going to be developing devices that interact with people. We also focus on teaching you about good research practice. This is really important. Whether or not you're going to be staying in research, you cannot understand the validity of the data that is publicly available if you don't understand the core principles behind research. And we have a full half of our modules, so half of the credits you're going to learn are from research projects, whether in group or individual. Finally, we have a range of optional modules which you can choose from. I've just listed 5 of them here to give you an idea of the range of modules and the types of topics you can take. I must stress that optional modules are not confirmed as running until January 2023. So those that are listed here, those that are listed online, are what we know is available this year. When you register with us, these may or may no longer be available. There may be timetable clashes, there may be student numbers issues. So they are an idea of what's available, but they are not guaranteed. And if you are very concerned about the availability of one specific optional module, I recommend that you email the new program director, Gavin, Hubin Zhao. Sorry, Gavin, I'm not lumbering you with another program. Hubin Zhao will be the new program lead, and he'll be able to interact with you more specifically on any optional module you're interested in. We have, in terms of our group research projects, we address real patient needs. We work directly with the Aspire Assistive Technology team, so they are working with real people with real needs of rehabilitation and assistive technology. Or individual research projects can have much broader topics. Again, the exact topics are not guaranteed at this stage, but they tend to be from pure research to working with healthy volunteers developing interventions that may one day be used for patients. The topics can cover human-machine interactions, haptics, rehabilitation robotics, some smart wheelchairs, some mobility. You can see more of the research we do on our website at ucl.ac.uk/aspirecreate. We're very multidisciplinary, so we're always opening opportunities for collaboration and development of new project topics. I'll just say briefly a couple of points here about research careers, and this to some extent is also answering some of the questions that I've seen on the Mentimeter. So I'll join the two together here. In terms of the careers that our alumni have had, they are international. So to answer the question on Mentimeter, the person asked, will doing a master's program here increase my chances of getting hired as an engineer over just having my mechanical engineering degree? And the second question was, will this program benefit me if I plan to study in Canada, to work in Canada after my studies? The answer to both questions is yes. Definitely, having an MSc will increase your chances of being hired over having a bachelor's degree in mechanical engineering. And most certainly, if you want to enter in a field that is linked with, that links engineering with healthcare, definitely having an MSc that has taught you about such concepts is extremely important. And having thought about the anatomy, the physiology, and some elements that you haven't learned. Obviously, as a mechanical engineer, you'll know about mechanics, and you might have had some biomechanics. You learn a lot more applied biomechanics in this master's. So it increases your chance of getting a degree. It also increases your chance of getting a degree because you'll have had an extra degree, getting a job. It also increases your chance of getting hired because any MSc in engineering from UCL will increase the value of your CV and the value of you as a new recruit in any company that is hiring engineers. It does benefit even if you plan to work in Canada. We have a widely international cohort, and students tend to travel further after their studies. Some return to their country of origin, other carry on traveling. So for example, we had a Japanese engineer that worked with us, then went on to do a PhD in Switzerland. We've had students travel through different countries. I mean, I don't know the trajectory of all of our students before, during, and after. We certainly have students currently working in across Europe and in other countries. I've listed a few here. So we're really proud of the locations and the destinations that all our alumni reach. And although I haven't got Canada on this list at the moment, I'm very eager to add it to it. So, you know, I've no doubt that the value of a UCL MSc degree will be recognized as far abroad as Canada. In terms of what directions your career can take, we do have students who carry on and become PhD students, research assistants, lecturers, and they again will be in a range of universities across the world. We also have a lot of our students going on to working in industry. We have a LinkedIn page that our MSc students join. And once you've been an MSc with us, you create this network, which means that you'll have the opportunity of chatting with former students of us, finding out what they're doing, getting advice, maybe talking about potential internships and other options to further develop your career prospects. So I'm going to just double check that I had it. Yeah, I don't have any other question or any other thoughts. So I leave this here and over to you, Hannah or Chaozong, if you're still on the call. Sorry, I can't see the participants at the same time.
Thank you, Anne. Chaozong, over to you.
Thank you very much. I will share my screen. Can you see my screen?
Yep.
Thank you very much. So good evening. I'm Chaozong Liu. I'm professor of physical bioengineering. I'm leading UCL Musculoskeletal Science, this program. So this program is running at the Royal National Hospital. So in this hospital, we collaborate with the clinician closely. So UCL, the Institute of Orthopedic and Musculoskeletal Science, provide unique environment for collaboration between scientists, engineers, and the clinicians in academic health science site model in order to speed up the development improvements in patients' care. So the university, with the Institute of Orthopedic and Musculoskeletal Science and the staff from the Royal National Hospital, we are leading units of major importance in clinical care, and we are at the cutting edge of research and development in novel processes development, cell engineering, spinal surgery, osteoarthritis, nerve injuries, and disease of childhood. So for this program, UCL Musculoskeletal Science, so the student, after studying this program, they will be able to join the research force to address the unmet clinical needs. So unmet clinical needs mainly include, for example, musculoskeletal disorders, for the early diagnosis and intervention of the musculoskeletal disorders, such as osteoarthritis, osteoporosis, bone sarcoma, and avascular necrosis. We are also working with the musculoskeletal tissue repair and regeneration. It's in this area we covered, for example, cartilage defect, repair and regeneration, osteochondral defect repair regeneration, and soft tissue, for example, ligament and tendon repair regeneration, and heart tissue repair regeneration. We are also working with biomaterials. You can also using the biomaterials as a medical device for the repair and regeneration of the damaged musculoskeletal tissues. For this degree, for this program, for the student on this MSc program, after the 1 year study, you should be able to acquire essential scientific knowledge, improve your basic research skills, and are equipped with the ability to solve musculoskeletal problems, emphasized with the AHS framework. So the program emphasizes the 4 major areas as identified by the bone and jaw decades, including arthritis, osteoporosis, trauma, and spinal disorders. You will be equipped with the transferable skills and research methodology in orthopedic bioengineering. So actually, this program we designed. This program is mainly for the one is for the medical trainees or MBBS students. So wish to take their career to the next level in orthopedic and musculoskeletal and sports medicine. We are also aiming for the student, for the complementary medicine professional, nurses, physiotherapists, and other allied healthcare professionals. So this program also a multidisciplinary program where also this course can be suitable for the bioengineering, biomaterials, and biological graduates who wish to develop their career in the healthcare sectors. So in this program, so the student it will learn some technology and the new knowledges about the musculoskeletal science and musculoskeletal medicine through the 8 taught modules and 1 research program. As for the 8 taught module, we have 4 core modules. These 4 core modules including is a clinical aspect of the musculoskeletal medicine and the surgery, part 1. So the second module is musculoskeletal biology. The third module is regarding the biomechanics and biomaterials for musculoskeletal systems. We also have a research and methodology program so that the students they can understand how you can do the research in the musculoskeletal research field. For the second term, so the student will offer the student 4 modules out of 5 option modules. So this including the clinical aspect of the musculoskeletal medicine and surgery, part 2. So we are also offer the musculoskeletal biology, part 2, and the biomechanics, biomaterials for musculoskeletal applications. We are also offer the student a clinical experience in musculoskeletal surgeries. For example, this clinical experience module, we will write this module in the Royal Free Hospital. Apart from these 8 taught modules, we have 1 research project. So the research project will take about 90 credits. So we'll take the 3rd term, the whole term will dedicate to the research project. For the research project, we are including the basic research science, the project. We are also including the lab work, also including the lab work. Also, there is a clinical relevant research project for the student to select. So apart from the desired research project, so we are also offer the student with the possibility to design their own research project. If any student, they have specific research interest in one area, so we can help the student provide the resource to you, so that we can support you to develop your own research project. So that after is that you successfully complete 8 total program, 8 taught modules, and 1 research program, you will be awarded MSc degree. So once you started this program, so the student will offer the student from a wide variety of the disciplines. This will enable the student to take the opportunity to gain a higher degree in an exciting and rapidly developing field. And this program equip you to make a strong contribution to the development of the musculoskeletal service. So the student can develop their careers in the healthcare sectors, medical device industry, and the biomedical industries, and also including the tissue engineering, regenerative medicine field. The student will also help student find a job in the regulatory bodies, such as well as in the academic communities. So some of the students, they have the opportunity to migrate to a PhD study after studying this MSK program at UCL. So that is about the UCL MSK program. So if you have any question, I would like to answer your any questions. Thank you very much.
Thank you very much, Chao Zeng. And now we will open the floor to any questions. Equally, I know that I have a couple of pre-submitted questions, but please do submit any questions you have, or feel free to raise your hand and we can obviously bring you onto the screen for our speakers. Well, as we haven't got anything in the Q&A function at the moment, I might fire off with a question that I have actually, which was submitted before the event. So this question is about the teaching style. So this prospective student is interested in finding out whether the teaching will take place online or in person. So I don't know, I think that's a general question to everyone. So perhaps Gavin, would you be able to lead on that one?
Yeah, sure. Both. So so the question was, are we going to be delivering online or in person, or how is it delivered? It really depends on the course in terms of how much face-to-face, oh, gone very blocky, that is going to be delivered. There is a large component that's going to be face-to-face if you're in most of the MSc components. There are some modules which are delivered online. All the modules have online materials which you be able to look at. So there's storylines or like pre-recorded lectures for you to look at beforehand, quizzes and other interactive online materials. I'm thinking of the MSc courses that we run. Unless they specifically say that they're distance learning, you would be expected to be at UCL to partake in the face-to-face learning. I saw a question that's related to this about part-time, this is for the musculoskeletal in particular, in terms of what days the lectures are. But in generally, most of the courses that we run are part-time or flexible. Part-time means delivered in 2 years, flexible means delivered over 5 years. The part-time ones will have a specific modules you have to do in each of those 2 years. So modules in the first year, modules in the second year, as opposed to the flexible one, which will be modules, more flexible approach over the five years. Anne, you've got your hand up now.
Just about the question of, is it possible to work part-time alongside the MSc, whether musculoskeletal science or the other one? The challenge you will have is that it's not the same day of the week that the teaching will take place every week. And so, yes, it's possible, and we've had several students working part-time along or masters. I don't know whether the MSK has a specific offer part-time. I'm just looking at it. At the moment, I don't see it as being offered part-time this year. But whichever one you go for, be aware of the fact that part-time isn't one where you select that you're going to be working every Thursday, for example, in your job, and be taught every Monday and Tuesday. There will be variability throughout the year, depending on the module you're taking, as to when the taught days are. And this has been, it hasn't stopped some students working alongside the MSc, but it's not always possible.
Thanks so much, Anne. Xiaozong, I don't know if you had anything you wanted to add.
Yes, can you hear me? Yeah. So for the MSK program, this program is mainly running in the Royal National Orthopedic Hospital. So normally for this program, we have small cohort every year. So for the teaching, it's normally is that for the first term teaching, is that first term teaching. Normally, we arrange the teaching on Monday, Thursday, and Friday. So the Tuesday afternoon is for the research methodology study program. So this year, so research methodology Tuesday afternoon, the student provide opportunity for the online learning for this year. So that the Wednesday is free for the student. Wednesday we decide as a reading day for the student. They can working at home or just self-study. For the term 2 teaching, we offered this term. We using a block teaching. Monday, that the teaching will be, clinical aspect we allocated on Monday. It's a Tuesday, it's a biology, musculoskeletal biology module. Wednesday is for biomaterials and biomechanics module. Thursday is for the clinical experience module in Royal Free. A Friday for the research governance. So that depends on, for example, if the student registered as a part-time student, it depends on which module you are selecting. So the teaching, is maybe arranged on different date. For all of the teaching after the lecture, we will upload all the lecture materials with the radio record to the Moodle, so that to help to support the student, is that after class learnings.
Fantastic, thank you.
Thank you.
So I can see we have quite a lively conversation going on in the chat. I don't know, Anne, did you want to elaborate on your answers?
Yeah, I mean, just to say, I see that it's great to have a person that's interested. I noticed that it's for next year, not this year. I think for next year, it will be a similar situation to this year. We're trying to keep the class size on all rehabilitation engineering MSc to about 10 students to enable really hands-on work in all labs and making sure that everybody has access to the equipment. Also for the projects, it means that you get more one-to-one interactions with the supervisor. I don't imagine this will change for next year. I don't think we're going to grow the size significantly. Maybe 15 if we get more as we grow the number of staff that can work with the students. But even then, if you apply early and if you write a strong application letter, it's your interest we're looking for. We want a range of students with different backgrounds. So as long as you meet the grade requirements, your background is fine. What we're looking for is, why are you excited to work in this field? We want to train rehabilitation engineers that are going to make a difference. So that's what we're looking for.
Perfect. Thank you so much, Anne, for explaining. I can see, I'll just go through the chat again to make sure I haven't missed anything. I think we're all up to date with that one. Carolyn says thank you. So we look forward to seeing your application. Fantastic. I've got just a couple of questions which were pre-submitted. I'm aware we've only got a couple of minutes left. But I think this is always quite a nice one, actually, that we do get from prospective students. So what inspired you to go into your careers? So I don't know if we want to start with Gavin.
I think, I don't know if there's a direct answer to this. In terms of the actual degree subject, I started off as a biologist more, and then did a PhD. What was I to do first? I did an MSc in parasitology, and then from that became interested in how parasites interact in the body. And from that, I went into orthopedic implants, which is not an obvious jump, but they're both foreign bodies, you could say, that are part of the body, and how understanding how the body responds to those foreign materials. I think academia is it's not for everybody. It's a long pathway to get there. But I certainly really enjoyed my job. I enjoyed the teaching, and I enjoyed in the research. So there's a short answer to saying I don't really know how I ended up there, but I did.
Thanks, Gavin. And I don't know if Xiaozong and Anne, if you want to summarise very quickly. I know we're out of time, but just a few words of what inspired you, that would be fantastic.
Yeah, I'll jump in with a few words. Helping people. That's what inspires me.
Fantastic. And Xiaozong?
Thank you. If you have any question, have any interest regarding MSK program, feel free to contact me or Ruth. So we are looking forward. You study at UCL. Thank you.
Fantastic. Well, thank you so much, Xiaozong, Gavin and Anne, for your excellent presentations. And thank you so much to those that submitted questions and for everyone that joined us today on the call. We do have a very quick survey for you to answer following today's event. So if you can let us know how you found it, and any feedback would be greatly appreciated. Equally, all of our speakers would be delighted if you contacted them directly if you have any questions following today's event. But in the meantime, thank you so much again to our speakers, and we hope that you all have a wonderful evening. Take care, everyone.
Bye.